Hello, this is Mrs. Maxey. This is a video for Nat 5 applications and maths, specifically for the Nat 5 numeracy unit. This video is looking at appreciation, depreciation. When we come to banks, we were talking about compound interest. And we're going to start off by looking at this situation here. Peter wants to invest £1,000 into Santander's savings account, and on the left-hand side here, we've got the details about Santander's account. So it's 2%, so that means that after each annual, so each year, he'll gain 2% on the money he already has in the account, but it's called compound interest, and we're going to look at how this compound interest works. But basically it means that at the end of the first year, we'll figure out 2% of the amount that's in the account and add it on. At the end of the second year, we'll figure out 2% of what is in the account at that time and add it on. And notice that because every year there's more money in the bank, the amount that's added on, the 2%, will be bigger. So how much money would he have in the account after 3 years if he didn't withdraw anything? Let's have a look. So at the beginning of the first year, he started with £1,000, and if you figure out 2% of £1,000, it's £20. Add that on, and that tells you that at the end of the first year, he'll have £1,020 into the account. So that means at the beginning of the second year, he'll also have £1,020 in the account. So at the end of the second year, we're going to be adding 2% again, but this time it will be 2% of a different amount. It won't be 2% of £1,000. It'll be 2% of £1,020, which is actually £20 and 40 pence. So it is slightly different there. Okay, and that means at the end of the year we're adding on £20 and 40 pence, so it is a tiny little bit more that we're adding on, and that means that at the end of the second year Peter will have £1,040 and 40 pence into the account. Then in the third year, he'll start off with £1,040, and we'll add 2% of £1,040 and 40 pence, which is about £21 and 21 pence. And when we add that on at the end of the year, we can see that it's £1,061 and 21 pence. So you can see that the 2%, the amount that 2% is changing, because each time it's 2% of a different amount. Okay. Now we can look at these questions for things that are depreciating or going down as well in value. Here's an example. Ned buys an iPhone 6S for £539. It depreciates at a rate of 53% per year. How much is his iPhone worth after 3 years? And I used a table to do this, and I've already started it off. So at the beginning of year 1, the question tells us it's £539. It's depreciating, so going down at 53%. So we need to find 53% of £539 and take it away, which leaves you with £253.33. So at the beginning of the second year, he's going to have £253 and 33 pence in the account. So I'd like you to finish this question by finding the value at the end of, the second year by taking 53%. This time it'll be 53% of £253 and 33 pence, and take that away. Pause the video and give that a go. Okay, so I got that at the end of the year, taking 53% of £253 33 pence and taking it off. I got £119 and 7 pence. So at the beginning of year 3, we'll start with £199 and that should read £119 and 7 pence, and at the end of that year, once we've taken 47% of £119 and 7 pence off, we get £55 and 96 pence. That's actually a real life question. I know this is for when iPhone 6S's were brand new, and that's actually what it was worth after 3 years of the iPhone 6S being brought out. Now, if you're getting the decimals a little bit wrong, that might be because of your rounding, so make sure you're rounding your answers. Now, the problem we have is this is really, really time consuming, and we want to look at an easier method, and there is an easier method. What you are doing is you are taking 53% off 3 times. So if you're starting with 100% and taking off 53%, That means 100 take away 53 is 47%, and you're doing that 3 times. It's not times 3 because 53% is a different amount. It's going to be a power. It's going to be a power of 3. We're doing 47% times 47% times 47%. So let's look at calculating this. So this is a bit of a formula. So I say that the new value is the percentage which we have to write as a decimal to the power of the number of times we do the increase or decrease multiplied by the original value. You might want to pause the video and make sure you have a note of that. But here's an example question. I'm just going to do some covering up. So it says Mr. Mystery put £7,300 into his son's bank account at the start of this year. The account pays 3.2% interest per annum. How much will be in the account in 3 years' time after interest if no money is withdrawn or deposited? So going back to that formula, we need to know the percentage, the number of times we're increasing or decreasing, and what we started with originally. So that's what I'm going to start by doing. I'm just going to list that information down. So here I've got that the original amount is £7,300. I know that we're starting on 100% and it's going up because it's interest by 3.2%, leaving with 103.2%. Now, I don't have a button in my calculator which is percent. It doesn't work like that. So we have to change that into a decimal. You change that into a decimal by dividing by 100. Divide that by 100, you get 1.032. And we also need to know the number of times it happens, if it's working out after, if it's interest per annum, and that's happening for 3 years, it's going to happen 3 times. So now we can look down that formula, and I did say in class, if you don't want to write that formula down, that's fine, but just remember that you want the original times by the percentage to the power of the number of times it happens. And the original is 7,300, and we're using this decimal here, 1.032, and it's to the power of 3. Put that in your calculator and you get this number here, so then you just have to do some rounding. £8,023.46. I've put on the ticks so you can see where you would get marks for this question in an assessment. You get a mark for figuring out that you're going to use 1.032, a mark for knowing that you're doing 7,300 times 1.032 to the power of 3, a mark for writing your answer, and then a mark for rounding it. We'll do one example now, which is going down. So I'll just find one. Here it is. So here's an example where we're going down. So it says Paul bought a new car for £8,000. It depreciates, that means goes down at a rate of 23% per annum. How much would the car be worth after 4 years? So exactly the same thing. We're going to write down the information we've got. So the original is £8,000. We're starting at 100%, and this time it's depreciating, so it's going down by 23%. Meaning that we've got left with 77%, which we can change into a decimal by dividing by 100, 0.77. How much will it be worth after 4 years? So I'm just trying to move my bar down a bit. There we go. So our number of times it's happening is 4. Then what we're going to do is use that formula. So we're doing the original multiplied by the percentage to the power of 4. 8,000 times 0.77 to the power of 4. Put that in your calculator and this is what you get. We need to do some rounding. Money's always 2 decimal places unless the question says otherwise. So £2,812.24. Key things to note on this question is that because it's going down, for some reason people think that's going to mean that we divide, but you don't. It's going to still be multiplied, but the decimal will be less than 1. Okay, before when it was going up, it was 100 and something percent, so we got a decimal of 1 point something. Now we're going down, so it's just going to be like 77%. It's not going to be in the hundreds, so it's going to be 0 point something when we change that into a decimal, and that makes the number get smaller. They are 2 questions.